Okay, so today we're going to be doing problem solving with annuities and perpetuities. So this is Year 12 General Mathematics, Unit 4, Topic 1, Loans, Investments and Annuities, and Subtopic 3.2. So what are our syllabus descriptors that we're going to be addressing today? And it is pretty much to solve problems involving annuities and perpetuities as a special case. So particularly looking at the future value, present value, using future and present value tables, and then doing some problem solving with perpetuities. So calculating the future value. We've looked in previous videos at using a recurrence relation to work out the future value of annuities. And so today we're going to be using a formula to do that. I really like formulas. So here's our formula for the future value of annuity. So A is the future value, M is the amount of each regular payment. So I is our interest rate expressed as a decimal per payment period. So if it's monthly, it'll be like divided by 12. And so here is our future value of the annuity formula. Now, QCAA provide a formula sheet for you in the exam, and we provide it for you in your unit exams. And so where is that formula on our QCAA formula sheet? So if you look in the finance section, and you go down here, it's got annuities. Like here's our recurrence relation for annuity. Here is our annuities formula. So you don't have to remember the formula off by heart, you just have to be able to know where it is on the formula sheet that's provided. Okay, so what about calculating the present value? Now, if you looked at the formula sheet, there wasn't one for present value on there. So the present value of an annuity is the single sum of money that, if invested in the same terms as the annuity, would produce the same value in the future. So here's our present value formula. Here's the formula that we just looked at on the formula sheet. And there are some similarities between the two of them. So if you look here, the M is the same. The top line of 1 plus I to the n minus 1 is the same. But our dividing line has an extra 1 plus I to the n in it when we're dividing. So over here we're just dividing by the interest rate. Here we're dividing by the interest rate multiplied by 1 plus I to the n. So if you can remember this, then you just know that you need to add the extra 1 plus I to the n to work out the future value, the present value. Okay, what about if we have to work out the payment? So here is our formula for working out the payment. So where M is the amount that's going to be invested regularly or withdrawn. A is our desired future value. And so this equation here also isn't on the formula sheet. So how do we remember it? Okay, so this is one that's given to us, and it is very similar. So if we look at the A and the M are swapped around here, and here we've got I as our numerator, whereas on the when we're working out the future value, I is the denominator, and our numerator down here is our denominator there. So we're just literally reciprocating the two bracketed items in here. Future tables. What are future tables? So a table is sometimes created, and it's usually when we're doing large investments where we can work out what $1 would give and then multiply by this value in the table. So if we look here, if we were investing at something at 5% for, say, 6 years, we would go down the column 5, cross to 6, and then we would, so we had 5%, 6 years, and we'd get this 6.8019, and we would multiply whatever value of the annuity that we invested by. And we can also generate present value tables. So just like a future value, if we look down at the percentage that we want and the number of compounding periods, we'll get a value to multiply, which represents what $1 will be worth, and then we would go back and multiply by however many dollars that we put in. Perpetuities. So perpetuities are a special kind of annuity. Right? So if we had an annuity where we were subtracting, say, $1,000 every year, eventually the money would run out. Right? But with a perpetuity, it goes on forever. It goes on perpetually, like a perpetual trophy. And so scholarships and bursaries are examples of perpetuities. And the special thing about a perpetuity is that the interest that is earned on the investment is the same as the amount of the funds that is being paid out, so that the investment stays the same amount the entire time. So there is a formula for perpetuities, and here it is here, which is A equals M over I, where A is our amount that we've invested for the life of the perpetuity, M is the amount that's getting paid, and I is the investment interest rate per period. Okay, so we're going to do some examples now. Okay, so using the annuity future value formula, calculate the future value of a $500 invested every 6 months for 10 years at 6% per annum compounded 6 monthly. So let's write down what we know. So we're trying to work out the future value. We have $500 invested every 6 months. So our interest is going to have 2 compounding periods per year. So we have to put our percentage rate as a decimal, and because we have 2 compounding periods, we divide it by 2. So our interest rate is 0.03%, so 3% per compounding period. We have 10 years with 2 compounding periods per year, which is 20 compounding periods. Write down our formula. Substitute into our formula, and I don't know about you, but I can't do this in my head, so I'm going to get out my trusty calculator and turn it on. So 500, open brackets, 1 plus 0.03, close brackets. That's not what I wanted to do, so clear. 1 plus 0.03 to the 20. Make sure my cursor goes over, take 1, close my bracket again, divided by 0.03 gives me $13,435 at 0.18724. Now don't forget we're talking about money, so we need to round this to the nearest cent. So it's going to be $13,435.19. So here we are here. So to the nearest cent, in 10 years' time, our future value of the annuity is going to be $13,435.19. So let's do another example. This time we're working to work out the present value of the annuity. So using the formula for the present value of the annuity, determine the present value for $1,500 per year for 10 years, invested at 5% per annum. So we don't have any compounding periods this time, it's just annually. And then it says, hence in the context of this problem, explain what that means. So let's write down what we know. So our present value is what we have to find. We're putting $1,500 in per year. Our interest rate is 5%, so expressed as a decimal, that's 0.05. 10 compounding periods. Here is our present value formula. And if you remember from the first couple of slides, the difference between the present value and the future value is that we have not just I on the bottom, but I multiplied by 1 plus I to the n. So we've got this extra step on the bottom. Okay, so we're going to substitute in. And once again, I don't know about you, but I need my trusty calculator to work out the answer. So I'm going to bring that up here. I'm going to clear everything. So $1,500 times, and I'm going to put a bracket in, 1 plus 0.05 to the 10. Make sure my cursor goes over to the -1. And then down here, going to have 0.05, open bracket, 1 plus 0.05 closed to the power of 10. Go across, press enter, and I get $11,582.603. So 60239. Once again, it's money, so that's going to round down to 60 cents. So $11,582.60. So we've answered this bit and says now, hence in the context of this problem, explain what that means. So the present value of the annuity is $11,582.60. This means that this amount of money invested now as a single sum would have the same future value as $1,500 put in each year for 10 years at 5% interest. So this is explaining what the present value means. Okay, example 3, calculating the payment amount. So calculate the annual contribution needed to obtain $50,000 in 10 years with 4.5% per annum compounded annually. So what do we know? We know that $50,000 was invested. We need to find out the annual contribution. Our interest rate is 4.5% expressed as a decimal, and it's compounded annually, so we don't have to divide by anything. And we have 10 compounding periods. So here's our equation. And remember, our equation from our QCAA formula sheet, it's inverted when we're trying to find out the payment amount. So we substitute into the formula, and I can't do this in my head, so I'm going to get my trusty calculator out, clear my previous data, $50,000, large bracket, 0.045 on the top. Right. And we're going to have a small bracket down here. 1 plus 0.045 close brackets, raise to the power of 10, cursor across, subtract 1, cursor across, close brackets, enter, and I get $4,068.94. So there we are there, $4,068.94. So a regular payment of $4,068.94 is required to obtain $50,000 in 10 years' time at 4.5% compounding annually. Okay, our next example is going to look at future tables. So use the future table to find the future value of an annuity where $1,500 is deposited at the end of each year. That account pays 7% interest compounded annually for 9 years. So here's our future value table. We're looking for 7%, so we're going to be looking down this column here, column H, 9 years. Now make sure you're not looking at the number in the spreadsheet, but you're actually looking at the period number. So 7%, 9 years, here's our square. That we're looking for. So we look up the value for $1. We multiply our $1,500 by the value for $1. We get $17,967. It's as simple as that. What about going backwards and using the table for present value? So Liam invests $750, 6% for 8 years compounded annually. So here's our table, 6%, 8 years. So it's going to be this square here. All right, so we look up the table for $1. Our present value is going to be 750 times this. And we get $4,657.35. Okay, our last example, perpetuities. Okay, so a wealthy businesswoman decides to set up a scholarship fund to assist disadvantaged young people in her community. She wants to make sure that regular payments of $500 per month comes out and the interest rate is 6%. So let's write down what we know. So 6% as a decimal is 0.06. It's compounded monthly, so we have to divide by 12 to get our interest rate per period as 0.05. Our payment amount is going to be $500. We need to know how much we're going to invest into this scholarship. So here's our formula. We substitute into our formula. So 500 divided by 0.005. So get out my trusty calculator, clear the data there. So 500 divided by 0.005, press enter, and I get $100,000. So $100,000. So the woman needs to invest $100,000 to provide a regular monthly income of $500 per month. Well, what if we need to do some problem solving? So Genevieve's grandparents set up a perpetuity to help her pay for her tertiary education. They're going to invest $125,000 at 4.5% per annum with an interest rate compounded quarterly. Calculate the amount of Genevieve can pay off for university fees per quarter. So we're calculating M. So what do we know? The interest rate is 4.5% expressed as a decimal. It's compounded quarterly, so we have to divide by 4. So the interest rate as a decimal per period is 0.00125. So we're working out N. So here's our formula. M is A times I. So here's our rearranging triangles. So if I want to find M, I put my hand over M, and that's A times I. So 125,000 times 0.00125 gives me $1,406.25. So this investment of $125,000 gives Genevieve $1,406.25 each quarter. But her grandparents want her to get $2,000. So they're going to shop around for a better investment rate. Calculate the interest rate that is needed to get $2,000. Okay, so now this time we're looking for I. We want $2,000 to be the amount that she gets. It's the same amount of money that's getting invested, so it's the same amount. We need to find I this time, so if we put our hand over I, that leaves M divided by A. Alright, so our M is 2,000, our A is 125,000, which gives me 0.016% per period. Now remember, this is a decimal per period. How many periods per year? Because we've got to work out the annual interest rate that's needed. So there are 4 compounding periods per year. So we have to multiply this by 4. And we also need to multiply by 100 to move it back to a percentage rate. So we're going to multiply by 100 to get it back to a percentage, and multiply by 4 because there's 4 compounding periods. And so that will give us an interest rate of 6.4%. So Genevieve's grandmother needs to get an interest rate of 6.4% in order to get a payment of $2,000 per quarter. Okay, so it's time to do some individual practice. So I want you to answer the questions in exercise 9.4 on page, that should be page 305 of your textbook, not page 3.5. Then you're going to complete your study on chapter 9, concepts 2 and 3. Once again, make sure that you end any previous sessions first. And when you submit for marking any questions that are extended response, you need to mark those yourself. Here's our summary sheets for concept 2 and 3. So perpetuity, here's our perpetuity formula. Don't forget when you're doing your study on, you're looking for the green tick. And here are our summary sheets for calculating the future value and the present value of investments. So pause the video here, come back in a few minutes when you've had a chance to do the questions. I'm going to go through concepts 2 and 3 from study on, and so when you come back you can check your answers. Okay, so I'm assuming that if you're back, you've done your study on and you want to check your answers. Okay, so I'm going to go through the practice questions, and we're first going to do concept 2. Concept 2 deals with perpetuities. So that's our A, I, and M formula that we need to be able to work out. So, question 1. An ex-student would like to provide an annual trophy for their former school by setting up an account that will pay for the trophy each year. That's very nice of them. So interest rate is 3%. what's the minimum amount that the ex-student should invest? So we're looking for A, right? And the trophy is going to cost $100, so that's going to be our M. So here's our working. I equals 3% expressed as a decimal. M is $100, and we're trying to find A. So here's our formula. A equals M on I. 100 divided by, 0.03 gives me $3,333.33. And I can see that is the answer D. And so my answer is answer D. Question 2. A grandmother sets up an account for her first granddaughter so that she will receive a $200 birthday present each year. If the grandmother invests $4,000, what's the interest rate required? So we're looking for I, right? So that the perpetuity continues. So we're looking for I. $200 per year is the payment amount. $4,000 is the original investment. So plug that into our calculator and we get 0.05% per period. Right? And it's an annual period, so we have to just multiply by 1. And to convert it to a percentage rate, we multiply by 100. And so it's a 5% interest rate. So our answer is answer A. Question 3. So a benefactor left an amount of $115,000 to the local bowls club. They're very generous. So the club committee decides to invest the money at 6% per annum. What is the maximum amount that they can receive if $115,000 is going to remain for as a perpetuity? So we're now looking for M. So 6% expressed as a decimal, looking for M. Our investment amount is $115,000. So M is A times I. Substitute in, and we get $6,900, which here is answer B. Okay, question 4. An annual scholarship is paid out of a $40,000 perpetuity, vested at 6%. What is the value of the scholarship? So once again, we're looking for M. So 6% expressed as a decimal. We're trying to find M. $40,000 is our starting amount. Put our formula, substitute in, and our answer is 2,400. Now, because this question is not a multiple choice but an extended response, when you mark this, you'll have to make sure that you've put your working and get all the marks that are allocated to that question. Okay, the last question in concept 2. Joel's grandparents decide that they will invest the money in a perpetuity to help their grandchild's university or school fees. So the interest rate is 3.5%. The amount that they want to get out per year is $2,345. So how much did they invest? So this time we're trying to find A. So let's write down what we know. 3.5% expressed as a decimal. They want a payment of $2,345. So here is our formula. Substitute in, and we get a value of $67,000. So Joel's grandparents will have to put in $67,000 to ensure that their grandchildren get $2,345 income per year. Okay, moving on to concept 3, annuities. So this time we're going to be looking at either using the annuity formula or using the recurrence relation. So Blair pays $450 into a superannuation account. So that's going to be the M value. For 5.8% interest per annum compounded monthly. So we have to divide that by 12 to get the interest rate per compounding period. The initial balance is $12,000. Calculate after 3 payments. So what do we know? So our R value is 1 plus the percentage. So 0.058 is expressed as a decimal divided by 12. So here is our R value for our annuity. So I'm going to write a recurrence relation. So at the end of the first period, it's going to be 12,058. Second period, $13,018.45. And at the end of the third period, it's going to be $13,551.38. So our answer is going to be answer D. Question 2. So this is an extended response question, so you'll have to mark this when you are submit for marking. So it says complete the following table showing payment made, interest earned, and the balance after each period. Okay, so here's my payment of $800. My interest is, here we have R is 5% per annum, compounding monthly. So 0.05 divided by 12 will give me 0.0041666. So we can see that here. Multiplying by our initial balance gives me an interest of $125. And that was already given to you. So we add on our $125 interest. We add on our $800 that we're paying into the account. So our final balance is $30,925. So for our second month, we're going to pay our $800 in. Our interest is going to be our interest rate as a decimal per period times by our previous balance, which is $128.85. And then we're going to add these on to get $31,853. And we do the same thing for the third one. So you need to make sure that this table is filled out in order to get your 3 marks. Question 3. Using the recurrence relation, so they've given us the equation where D is calculate the second value. So D is $1,100. Our interest rate is 7.5% nominal interest per annum compounding monthly. So our R is going to be 0.075 divided by 12. So what do we know? Our R is 1 plus 0.75 divided by 12. Here is our recurrence relation where we've substituted in the R times 1 plus our 1100. Now, we're told what our value is for A3. And we've got to work backwards to find out what our A2 value is. So here it says A3 is 28,000. So I'm going to substitute in 28,000 for my A3. Now I have to get A2 by itself. So I've got this $1,100 on this side. I have to take it to the other side. And so it's going to subtract $1,100. Okay, so I subtract the $1,100 to get $26,900. And I've still got my interest rate here or my R value. So now to get A2 by itself, I have to divide both sides by my R value. And when I do that, I get $26,732.92. So my second value is $26,732, and here it is as answer A. Okay, question 4. Using the annuities recurrence relation, calculate, what do we have to do? Calculate A3. Okay, so we have to work out what A3 is. So here's our R value. Sorry, here's A0. That's our starting value. We're adding $450 each time. So here is our equation. So A1, A2, A3. So our value after 3 is $222,012, and I've got 1 cent, but they've got, here we are here, so it's answer C. And our last question, I think it's our last question, so comparison between two super funds. Okay, so both these super funds have an initial balance of $100,000. So plan A is 6.8% compounding monthly with $800 added each month. Plan B is 5% compounding monthly with $950 provided each month. It says, how many months is the balance of each account the same, not including the initial balance? So we have to work out how many months they're the same. So, plan A, at 0 months, it's $100,000. Plan at 1 month, it's $101,000. 2 months, it's $102,000. 3 months, it's $104,000. Plan B, $100,000, $101, $102, $104. So how many months are they the same, not including the first one? So we can see here that the first month it's the same. Second month it's different. Third month it's different. So only one of the months is the same. So our answer is going to be B. Okay,